Problem 41, we're going to relate the argument of z to argument of z inverse. Now, what do we know about z and z inverse? Well, we know that z times 1 over z is 1. So what does this tell us? It tells us that the argument of z plus, well, let's be really careful here. Let's just apply argument to both sides. So the argument of z times 1 over z is the argument of 1. Let's just have a picture here to help us. 1 is the complex number that's 1 on the positive real axis, and that has argument any multiple of 2 pi. Argument of z times 1 over z is the argument of z plus the argument of 1 over z. And so then this tells us then that the argument of z is equal to the negative of the argument of 1 over z plus any multiple of 2 pi. So in particular, if z is making an angle of theta, then 1 over z makes an angle of negative theta. And actually, there's another way of going about this. So we derived a formula for 1 over z already. And the formula said that 1 over z is z bar over modulus z squared. So we know already this formula. It's how we computed reciprocals a while back. So what this tells us then is that the argument of 1 over z is the argument of a real number. This is just a number, real number. Multiplying by a real number does not actually affect the argument. So we can think about that. We can just get rid of that. We should have the same argument as z bar. And if we were to draw a picture, and we were to put z somewhere, z bar is negate the imaginary part, or it's reflecting the real axis. It means the same thing. So, in particular, the argument of z bar is also negative the argument of z, as we found already. And this is just an alternate way of going about it.